Presentation, we'll study the idea of a dummy variable in a regression model. Suppose we have a regression model, yi is equal to alpha plus beta xi plus ei. So the conditional mean of y depends upon the values of x. But what if x is not a numeric variable? What if x is a qualitative variable? For example, we could be wanting to study the relationship between average expenditure on ice creams of males and females. In which case the x variable will be whether the given person is a male or a female, which obviously is not a numeric variable. So how do we deal with these kinds of situations? So we write yi is equal to alpha plus beta gender I plus ei, where, as I said, yi is the expenditure on ice cream by the ith person. The ith person could be a male or a female. So it's the gender of the ith person. But since gender is not a number, how do you even measure it? That's where the idea of a dummy variable comes in handy. So basically, look at the data. Suppose we have data on expenditure. So the expenditure by the first person on ice cream is 20 rupees and the person happens to be a male. The expenditure by the second person on ice creams is 10 rupees and the second person happens to be a female, and so on. So what we now do is we recode gender. We code it as 1 if the person is a male, and we code it as 0 if the person is a female. This coding, which takes the value 1 for the first person, 0 and 0 for the second and the third persons, again 1 for the fourth person, 0 for the fifth person, and so on, is called a dummy variable, which takes the value 1 if the relevant person is a male, if the ith person is a male, and if takes a value 0 for the ith person, if the ith person is a female. So to recapitulate again, we have a dummy variable bi for the ith person, which takes a value 1 for the ith person if the ith person is a male, and which takes a value 0 for the ith person if the ith person is a female. How does this help? So consider the conditional mean of y conditional upon di is equal to 1. And that, as you can see from the equation, is alpha plus beta. That is the conditional mean of ice cream expenditure for males. Similarly, the conditional mean expenditure for females, that is expected value of yi conditional upon di is equal to 0, is alpha. It is the conditional mean for females. So what does alpha stand for? Again, to reiterate, it's the average ice cream consumption for females, because di is equal to 0 for females. Alpha plus beta is the average ice cream consumption for males. Beta is the difference between the two averages. So the important point is this: by choosing di is equal to 0 for females, we are choosing females as the reference category for ice cream consumption, and we're going to compare it to the consumption of ice creams by men by asking if beta is greater than, less than, or equal to 0. So if beta is equal to 0, then we would say that the average consumption expenditure on ice cream of males is not different from the average consumption expenditure on ice cream by females. On the other hand, if beta is greater than 0, we are going to say that the average consumption expenditure on ice cream by males is greater than that for females, and if beta is less than 0, we are going to say that the average consumption expenditure on ice cream by males is less than that by females. So basically beta tells you whether men spend more on ice cream than on an average than women do. So basically, again, to remember, the baseline category that we have, the reference category, is the average consumption expenditure by females, that we have set by choosing di is equal to 0 for females and sorry, and di is equal to 1 for men. We wanted to flip the reference categories. Instead of using females as the base category, or the reference category, you wanted to use males as a reference category and compare the average consumption expenditure on ice creams of females to those of males. Then you would choose the dummy variable di to be 0 if the ith person is a male and di is equal to 1 if the ith person is a female. In that way, we will flip the categories. So now consider the case where we have not two categories but three categories. Suppose I wanted to compare the average growth rate of incomes in districts of Western Maharashtra and Eastern Maharashtra to the growth rate of districts in the rest of the state. Then we can introduce the dummies. Di is equal to 1 if the district belongs to Western Maharashtra, 0 otherwise. Another dummy. So basically, because rest of Maharashtra is the reference category, we choose a dummy variable which takes the value 1 if the ith district belongs to Western Maharashtra, 0 otherwise. Similarly, we choose another dummy D2I which takes the value 1 if the ith district belongs to Eastern Maharashtra and 0 otherwise. And obviously, we don't have a dummy for the reference category. We have dummies for the two remaining categories which are being compared to the reference category, which is rest of Maharashtra in this case. So we have a dummy variable for Western Maharashtra and a dummy variable for Eastern Maharashtra, and then we run a regression. Y is equal to alpha plus beta 1 d1i plus beta 2 d2i plus ei. So condition mean of yi, condition upon di is equal to 1 and d2i is equal to 0 is alpha plus beta 1. Condition mean of yi given d1i is equal to 0, d2i is equal to 1 is alpha plus beta 2. And the condition mean of yi given di is equal to 0, d2i is equal to 0 is alpha. So as you can see from here, alpha stands for the average growth rate of districts in the rest of Maharashtra because that's the base category. We have chosen d1i is equal to d2i is equal to 0. Beta 1 stands for the difference between the average growth rates of Western Maharashtra and rest of Maharashtra, and beta 2 stands for the difference between the average growth rates of Eastern over rest of Maharashtra. So the rest of Maharashtra is being chosen as a base category. So now suppose we wanted to change the base category. Suppose we now wanted to compare the average growth rate of districts in Eastern Maharashtra. So Eastern Maharashtra becomes the reference category to the average growth rate of districts in Western and the rest of Maharashtra. Our dummies will have to change. We'll have to now introduce a dummy D1I which is equal to I1 if the district belongs to Western Maharashtra and 0 otherwise. Similarly, we will introduce a dummy D2I which is equal to 1 if the ith district belongs to the rest of Maharashtra and 0 otherwise. So regression equation would then be yi is equal to alpha plus beta 1 d1i plus beta 2 d2i plus ei. The condition mean of yi given d1i and d2i is equal to 0 is equal to alpha. This is the average growth rate for Eastern Maharashtra. Beta 1 would then be the difference between the average growth rate of districts of Western Maharashtra over the average growth rate of districts of Eastern Maharashtra, and beta 2 would stand for the difference between the average growth rate of districts in rest of Maharashtra over Eastern Maharashtra. So the key idea is you must choose your dummy variables carefully to reflect your research questions. You must very clearly understand what is your reference category, what are the categories that you're comparing with the reference category, and choose your dummies accordingly. Secondly, please remember that the number of dummies must be one less than the number of categories. So if three categories, one category works as a base category, so you have only two dummies for the remaining two categories. You cannot have three dummies with three categories. You can't then estimate the regression model. That's called a dummy variable trap.